Hello viewers, in this video we are going to learn about basic computer instructions in basic computer organization and design. Hello viewers, in this video we are going to learn about basic computer instructions in basic computer organization and design. Let us learn about basic computer instructions. Basic computer instructions can be classified into three types. Those are memory reference instructions, register reference instructions, input-output instructions. Though they are classified into three types, all the three instruction formats takes 16-bit size only. Okay. The first 4-bit values are used to classify the type of the instruction. Particularly to determine the type of the instruction, the opcode part of the instruction, that is 12 to 14-bit values are first checked. If 12 to 14-bit values are not set to 111, it is of type memory reference instruction. Okay. And again, in memory reference instructions, it can be classified into two more types based on the type of the address specified in the memory reference instruction. It can be classified into two types. That is, direct memory reference instruction, indirect memory reference instruction. Okay. So if I bit value is set to 0, then the memory reference instruction is said to have direct address in the address part of the instruction. And if I bit value equal to 1, then the address part of the instruction contains the indirect address of the operand. Okay. So this opcode value in memory reference instruction never have 111. Okay. And it may have any one of the values of the combination 000 to 110. That is, this 000, it is the binary equivalent of the decimal number 1, and from 1 to 6, that is 110, it is the binary value equivalent for the decimal number 6. So from 1 to 6 values only it can have in the opcode part. Okay. Whereas coming to the register reference instruction, all register reference instructions are having 111 values in the opcode part, and I value is always set to 0. That is, 15th bit of the register reference instruction is always set to 0. The remaining 12 bits of the register reference instructions are used for specifying the register operation to be performed. Whereas coming to the input-output instruction, the 12 to 15 bits are all set to ones. This opcode values and I bit value are everything are set to ones. And the remaining 0 to 11 bit values are used to specify the IO operation to be performed. Let us now discuss more about memory reference instructions. As we just discussed about memory reference instruction, the 12 to 14-bit values never be set to 111, and it can have any combination of these values 000 to 110. That is, with the help of 3-bit opcode, 7 different memory reference operations can be performed. Okay, it never be set to the opcode part never be set to 111, because this opcode, if it is set to 111, it represents that the type of the instruction can be of register reference or input output instruction. Okay. Um, um, so if suppose the opcode part of the instruction contains 000, then the opcode specifies the AND operation, that is AND memory word the accumulator. If the opcode part contains a 001, then it represents the operation and add memory word the accumulator, that is add memory word the accumulator. If the output part contains 010, it represents a load accumulated from memory. If 011 is there, then store content of accumulator into memory, and 100 represents branch unconditionally operation. 101 represents branch and save return accumulate return address. If that is 101 represents branch and save return address, 110 represents increment and skip if zero operation. So these operations, so out of these 7 operations to be performed, it need operands, right? So the operands memory address be specified in the 0 to 12 bit position of the memory reference instruction. Since as we just discussed, the address part of the instruction shall contain direct and indirect address, and either it contains direct or indirect, it is determined based on the I bit value. If I bit value is set to 0, the address part contains the direct address of the operand. If I bit value is set to 1, then the address part contains the indirect address of the operand. Here students, the 16-bit memory reference instruction binary code is present here, and this binary code, 16-bit binary code is for direct address, and this 16-bit address, it contains the memory reference instruction that contains the indirect address. Okay. So let us first observe only the 4-bit of memory reference instructions. In this, all the first 15th bit is set to 0. It means that the address part of the instruction contains the direct address of the operand. The remaining 12 to 14 bits specifies the opcode. So if we take the first instruction, since it contains 000 in the opcode part, this instruction will perform and the memory word the accumulator, where the whose memory word address is specified, direct address is specified in the address part of the instruction. Okay, so to perform this operation, by fetching the operand from the memory whose address is specified in the address part. So that operand can be fetched from the memory by taking the address, I mean by taking the direct address of the operand which is specified in the address part of the instruction. Then the corresponding operation can be specified. One operand usually be from accumulator and another operand for the AND operation is taken from the memory word whose direct address is specified in the address part of the instruction. Okay, and the result is also stored back into the accumulator. Students, one of the important point I do like to highlight here is that about accumulator is that whenever ALU operation is performed, one of the operand is usually be taken from the accumulator, and after performing the ALU operation is also the result is stored back into the accumulator only. So this is the very important point you need to remember whenever any operation is performed in the computer, okay, especially in the basic computer. Okay, let us take one example in memory reference instruction that contains the indirect address. Here you see for all the 7 instructions. So in all the 7 instructions, the 15th bit is set to 1. It means that the address part of the instruction contains the indirect address of the operand. If we take the first instruction, so since opcode contains the 000 values, it represents the AND memory word accumulator, where in the address part of the instruction, indirect address of the operand is specified. Okay, and equivalent hexadecimal code of the 16-bit binary code is present. Usually, since we are comfortable with hexadecimal code, whenever we learn about the basic computer organization, we follow the hexadecimal code. Here, I have explained with binary code value because to understand the concept very clearly, if we explain with binary code, then it is more easy to explain and understand. Okay, usually since hexadecimal code is very comfortable form, we follow hexadecimal code only whenever we learn about basic computer organization and instruction codes. So the same hexadecimal code format only represented in the textbook also. Okay, in register reference instructions, the 12 to 14 bit values are always set to 111 and the 15th bit is set to 0. The bit values from 0 to 11 are used for specifying the register operation to be performed. Okay, since there are 12 bits are allotted for specifying the register operations, with the help of 12-bit values, 12 different register operations can be specified. 12 different register operations can be specified. Okay, if you look at the 16-bit binary code of the register reference instructions. You can observe here. Um, you can observe here the 12 to 15-bit values in all the 12 instructions are all set to 0 1 1. And if you observe the 12 bits of the values which are allotted for register operations, uh, out of 12-bit values, only 1 bit values are set to 1. If 11th bit is set to 1, it indicates the clear accumulator operation to be performed. If 10th bit is set to 1, then it specifies clear extended bit operation. Then if 9th bit is set to 1, it represents complement accumulator. Like this, to represent 12 different register operations, out of 12 bit values, only 1 bit values are set to 1. Okay. So what are the 12 different register operations? Clear accumulator, clear extended bit, complement accumulator, complement E bit value, circulate right accumulator and E bit value, circulate left accumulator and E bit value, increment accumulator, skip next instruction if accumulator is positive, skip next instruction if accumulator is negative, skip next instruction if accumulator is 0, skip next instruction if E bit value is 0, halt computer. Like this, 12 different register operations are specified using the 12-bit values of register reference instructions. Okay. Let us now learn about input-output instructions. In input-output instructions, the bit values from 12 to 15 are all set to 1. So if 4 bit values are present in 15 to 12 bit values, that type of instructions are known as input-output instructions. And where the 0 to 11 bit values are used to specify the IO operation to be performed. Okay. Just let us look at the 16-bit binary code of the input-output instructions. You can observe here in all these input-output instructions, the first 4-bit values are set to 1s, and in the remaining 12-bit values, only one of the bit values is set to 1. Okay. So if 11th bit is set to 1, it indicates the input character to accumulator. If 10th is set, then output character from accumulator. And if 9th bit is set to 1, it represents skip on input flag. If 8th bit is set to 1, it represents skip on output flag. If 7th bit is set to 1, it represents interrupt on. If it is 6th bit, then it represents interrupt off input output operation. Here, the corresponding hexadecimal code of this 16-bit binary code is also represented. Okay. Students, if you find this video useful to you, kindly subscribe this channel. Thanks for watching.